This is Chapter 6, all about exponential functions and sequences. And this is specifically 6.1, Properties of Exponents, Part 1. So we know exponents are where I have a base, and an exponent is this small number that's raised. And this number that's raised means how many times the base is being repeated, or multiplied by itself. So if I have 4 to the third power, that means 4 times 4 times 4. If I have just a 4, I have an invisible 1 up here. So that means it's just multiplied by itself once, which is just 4. If I have an exponent of a 0, for any number a, where a is not 0, a to the 0 power equals 1. So whatever a is, it can be any number in the world. If it's raised to the 0 power, that equals 1. The power of 0 to 0, undefined. So, if I have 3 to the power of 0, that equals 1. If I have 1/2 to the power of 0, that equals 1. And if I have negative 12 to the 0 power, that equals 1. I can also have an exponent that is negative. For any integer n and any non-zero number a to the negative n power is the reciprocal, so that means you flip a fraction, of a to the n. So if I have a to the negative n, that equals 1 over a to the positive n. In flipping this fraction, so you can see it has a 1 on the bottom. When going to the reciprocal, my exponent changes from negative to positive. And so here, if it starts on the bottom, I use the reciprocal, and it's now in the numerator of the fraction, and it's positive. So if I have 4 to the negative 2, I'm going to use the reciprocal, moves to the denominator, and now my 2 is positive. So we're going to evaluate. That means get a number answer. So go all the way until you get a number. 9.3 to the 0 power, that's 1. Anything to the 0 power is 1. 3 to the negative 4th power is 1 over 3 to the 4th. That's 1 over 3 times 3 times 3 times 3, which is 1 over 9 times 9, which is 1 over 81. If I have negative 2 to the negative 3, that is 1 over negative 2 to the third power. So I have 1 over negative 2 times negative 2 times negative 2, which is 1 over 4 times negative 2, which is negative 1 over 8. Now we're just going to simplify. If I have 6x to the 0 power and y to the negative 7th over y to the negative 7th, I bring up my y, so now it's positive, and this x to the 0 power becomes a 1. So I have 6 times 1 times y to the 7th, which is 6y to the 7th. Here's the work on how I brought it up here. If I have 3 to the negative 2 times x to the 4th, I'm going to move my 3 squared to the denominator. X to the 4th stays on top, because its positive exponent stays. And so 3 times 3 is 9, so I have x to the 4th over 9. What if I have 3 to the negative 2 times x to the negative 5? These are both negative exponents, so they both go to the denominator of my fraction. I can simplify 3 squared, and that is 1 over 9 times x to the 5th. We're still simplifying, just doing a few more. 5 to the negative 7th power times x to the 3rd over y to the negative 4th power. my 5 has a negative exponent and y has a negative exponent. So 5 term, this term will move to the denominator, and my y term will move to the numerator. Now they're all positive, and I can simplify 5 to the 7th power. So, in doing that, 5 times 5 is 25, 25, 25, and another 5. 25 times 25 is 625. 25 times 5, 125. So this would be x to the 3rd, y to the 4th, over 78,125. And this would be my final answer here. Now if I have 3 to the 4th, x to the negative 6, and y squared, over z to the negative 8th. This negative exponent will move my x term to the denominator, and the negative exponent here on z will move z to the numerator. Now they're all positive, and I can reduce 3 to the 4th, which is 81. So I have 81 times y squared times z to the 8th over x to the 6th.